Okay, so only an experiment will give us cause and effect. It's the only way that we can justify a claim like music lessons cause students to have higher grades, taking vitamin C reduces the chance of getting a cold, and working with computers improves performances in statistics classes. So any sort of claim that we get a cause and effect comes from an experiment, and a well-designed experiment is required to establish cause and effect. Specifically, we need random assignment of subjects to treatment groups. So similarly to choosing a random sample, this is going to reduce bias and equalize variability, and we will get our cause and effect. And if we're not doing that, then why are we doing an experiment? It's not a good use of our time and money. So you want to make sure that you're randomly assigning your participants to treatment groups unless you have an extremely good reason why you're not doing that. There are maybe some very specialized, unique situations where that's the case, but it's fairly rare. All right, so let's define some of the terms involved in experiments. The first one is a factor. So we've had a couple names for this in this class. This is our independent variable. This is the variable that's on our x-axis. We've called this an explanatory variable, a predictor variable. And when we're talking about experiments, this is commonly referred to as a factor. So this is, the experiment revolves around the effect the factor has on the response variable. So this is the thing we're manipulating that we think is going to give us some sort of effect that we're looking for. Okay, the response variable, that's our dependent variable. This is the one that's on the y-axis. This is the outcome of the experiment, and it's to be measured or observed. So this is not something that we're manipulating. We're only manipulating the factor, and then we are recording its effect on the response variable. Okay, and usually we have a couple different treatment levels. So if we think back to the stretching example I used earlier, we have people that weren't stretching, people that are stretching 5 minutes a day, and then people that are stretching 20 minutes a day. And does one of those maybe work better than the other one? Okay, two variables are confounded when their effects on a response variable cannot be distinguished from each other. Okay, some people talk about this as you just can't tease apart these two variables to kind of determine what's going on. And a lot of times this can't be avoided. So here's an example. Professor Stephen Ceci of Cornell University, in the fall, he taught in a very subdued manner. Students rated him as average. In the spring, he taught way more enthusiastically, and the students rated him as excellent. Okay, so there is another issue going on here behind the scenes. Okay, and that is in the fall, especially as we're heading into winter. And I know some of you guys love skiing, so probably you're excited by the snow, but maybe there are people that are not so excited by the snow. It's their first semester as a freshman, and so by the time finals comes around, they're just really wiped out, and you know, the days are shorter, we don't have as much sunshine, and so maybe some of those effects of other things on their mood are affecting how they rate this professor. And in the spring, by the end of the semester, there's sunshine. I mean, goodness, it was like sunny here until 7:30 tonight, and it was gorgeous. And it's like, wow, sunshine, warm weather, and so generally in a happier mood, so maybe they rate the professor more favorably, right? So it's kind of difficult to tease apart those issues of the weather and his teaching style. Okay, so we'd have to design this a little bit differently to get at that. So we would call that a confounding variable. So at this point, we have sort of two variables that are problem children for us. One is a lurking variable, and then we've just added this confounding variable. So a lurking variable is usually found in an observational study, and it's usually the reason that we actually suspect we see the relationship. So if we go back to our ice cream sales and shark attacks example, what's really going on there is we think that it's summertime, so people are out swimming more because it's hot, and it's hot, they're also eating more ice cream, right? So we wouldn't conclude things like people are really sad to hear of drowning in the news, so they cheer themselves up by eating ice cream, or that it's more dangerous to eat ice cream before you go swimming. You know, my grandmother used to tell us that all the time. Oh, you've got to wait an hour after you eat before you get in the pool or you'll drown, right? So those kinds of things, right? That's not what's going on there. We really think that the issue is that it's summer, which causes people, it's hot, people eat more ice cream, people go swimming, which opens them up to being in a shark attack. Right? Confounding is a little bit of a different issue, and this usually shows up in experiments. So one way you can kind of tell the difference if you get really stuck is if it's a study, it's probably a lurking variable. And if it's an experiment, the issue is probably a confounding variable. And so these are kind of things that we can't always control for. So an example here is a store special promotion may increase video rentals, but the marketing folks cannot be sure that that's what it did if the weather was particularly bad during the trial period. Okay, so let's switch this up. Let's use an analogy that's maybe kind of more appropriate since we are all stuck at shelter at home situations, right? So I would imagine that the number of people that are subscribed to Netflix, Hulu, that are renting movies online has probably jumped dramatically, right? If you didn't have those services before, people probably have gotten those in the last week or two because we're kind of stuck at home and what else is there to do, right? So I don't know that you can really attribute that to some sort of marketing promotion they did as much as we're all stuck at home and we need something to kind of distract from that, right? Okay, so that would be a confounding variable there. All right, so on your classwork, this is the top of page 2. This is number 3. It's called Drink a Little But Not a Lot. So I'd like you to go ahead and don't stick your head in the sand. Pause the video and give it a try. So go ahead and do that. I'll come back after a couple seconds and we can discuss this. All right, so let's take a look at this. Many observational studies show that people who drink a moderate amount of alcohol have less heart disease than people who drink no alcohol or drink heavily. So they're defining moderate to be 1 or 2 drinks a day for men and 1 drink a day for women. That's how they've defined it, so we're going to go with that. All right, so we're going to identify the factor, which is kind of our explanatory variable. And I came up with that the explanatory variable is the amount of alcohol that is drank. Is that the right English verb, tense verb there? That people have consumed. And our response variable is going to be the amount of heart disease. Okay, so here's the next question. Is this an observational study or a controlled experiment? So this is going to be an observational study for a couple of reasons. It's pretty difficult to assign people to drink alcohol long term for something. There are studies that you can volunteer for. This is kind of interesting. A lot of times the police department or highway patrol will do a study where they have people come in. It's a very controlled environment. And you're interviewed by a police officer. They have you take 1 drink, and then you're interviewed again a half hour later. Then you drink a second drink, you're interviewed again, and so on and so forth, right? So they have you drink a number of drinks. That way the police officer can get a sense of what those interactions look like over the various times, amount of alcohol people have consumed over time. Right, so this is a very controlled situation. People are obviously not allowed to leave until they until the police feel like they satisfactorily, their blood alcohol level is dropped low enough that it's legal for them to be able to leave. Right, so something like that can be done, but when we're looking at alcohol and heart disease, that's a long-term effect there, I would assume is what they're going after. We can't really assign people to drink moderate or heavily or not for a long period of time. Additionally, if we think that there's some sort of relationship to heart disease and the amount of heart disease, it's probably not very ethical to assign them either. So this is going to be an observational study. It's the next question. Moderate drinkers as a group tend to be more likely to maintain a healthy weight, get enough sleep, and exercise regularly than those who drink no alcohol or, on the other end, drink heavily. So when we consider these lurking variables or confounding variables. Okay, so in this case, it is a study, which would make us think that these are lurking variables. And then some of these might be more likely to be responsible, right, for heart health. So maybe maintaining enough healthy weight is a better predictor of heart disease, or how much sleep or exercise you get might be a better predictor of the level of heart disease than how much alcohol was consumed. So we're going to call these lurking variables. The last question, is the association between drinking and heart disease a good reason to think that moderate drinking causes less heart disease? So again, this goes back to this is a study and not an experiment, so we don't get cause and effect here. So that would be no.